This is the beginning of Module 4, linear equations. Now we're going to work on linear equations, or we're going to work towards linear equations through Modules 4, 5, and 6. When we get through with this, by the time we get through with this, you should be able to compare linear equations using charts, graphs, data tables, equations, or word problems. Now, this first lesson, Module 4, Lesson 1, is going to be writing expressions from verbal descriptions. We're going to do a small amount of that just so you can remember how to write expressions from verbal descriptions. And then we're going to solve some one-step linear equations so we can build our way up into what we're doing. This first section, Standard 8 EEB 7 B part, is where we're going to solve linear equations in one variable with rational number coefficients. This includes equations with distributive property and collecting like terms. You're going to write math expressions from verbal descriptions and solve one-step linear equations. This all comes from Eureka Workbook, Module 4, Lessons 1 and 2, and the packet that I've got, page 1 and 2. You can find that packet in On Course. It's listed as Module 4 Packet, Part 1. Now, just quickly, some keywords when you're looking at word problems that help you decide whether you're adding, subtracting, multiplying, or dividing. Terms that would tell you you're adding would be plus, the sum of, increased by, total, more than, or added to. And there's more of them, but this is just a few. Some that would work on subtraction. Minus, the difference of, decreased by, fewer than, less than, or subtracted from. How about multiplication? You might see words like times, the product of, multiplied by, or of. That's a big one right there, of. Division, you might see divided by, the quotient of, or per. Per is one that you're mainly going to deal with on linear equations, because you might wind up with something like miles per hour, or miles per gallon, or days per the month, or something like that. Now, let's just look at some quick examples of writing equations using symbols, okay? If you're talking, let's look at number 3. We're just going to write the expression for this. Okay. Hold on. Great. If you've got an expression, if you've got a verbal expression, it says Stephen has some money. If he spends $9, then he will have 3/4 of the amount he started with. We're comparing to the amount he started with, so I'm going to say M is the money he started with. I always use a key so I can keep up with what my terms mean. Okay? All right, so if this is the money he started with, it's M, and he spends $9, what's he going to have? M minus 9. This says he will have 3/5 of the amount he started with. If M is what he started with, then M minus 9 is equal to 3/5 times M. He started with M money. He subtracted $9 because he spent it. That gives him 3/5 of the original amount he had. Okay? This is in your workbook. This is on page 1. All right? In your workbook, if you turn to page 7, we're going to look at a couple of these. Number 1 says, Bruce bought 2 books. We got 2 books. One book costs $4 more than 3 times the other. Okay, together the 2 books cost $72. All right. So what if I say, because we're comparing to one book, right? B is the cost of one book. All right. The other book is $4 more than 3 times this one. So I would say 3 times the cost of this book plus 4. That's the cost of the second book, right? Okay. Together, they add up to 72. So B is the cost of one book. I want to underline it so you'll understand that's one of the books. Plus the cost of the other book is 3B plus 4, isn't it? That's the second book. Add together the first book plus the second book, and you get 72. Okay, there's the equation. Let's look at number 2. Janet is 3 years older than her sister Julie. Janet is 3 years older than Julie, right? So we're comparing to Julie. Let's start with this. J's equal to, and what are we talking about with Julie? We're talking about Julie's age. See, I'm setting up my key here. It says Janet is 3 years older than her. So wouldn't it be Julie's age plus 3 would be Janet's age? All right. Then it says Janet's brother is 8 years younger than Julie. So if I take Julie's age and I subtract 8, that's going to be the brother's age, right? The sum of all their ages is 55. So if I add up Julie's age, Janet's age, and the brother's age, it'll equal 55. Julie's age, see, plus Janet's age, that's Julie's age plus 3. All right, plus the brother's age, Julie's age minus 8. Together, those three add up to 55, okay? Now, that's how this works, guys. We're just trying to go through and write some of these as word problems. Turn with me to page 9, workbook page 9. Let's look at this first one. The sum means add, the sum of a number and 4 times the number. Well, if I say n is the number, n is a number, then if I add up n plus 4 times that number, 4n would be a second number, right? N plus 4n. And it didn't tell me what it equals. They just wanted me to set up this expression. How about this one? The product of 5 and a number. Product means multiplying, right? 5 times a number. That's product, okay? That covers everything we're going to look at there. Look at workbook page 10. Okay. This is 4 subtracted from the reciprocal of a number. Reciprocal is 1 over the number, right? You flip it over. 1 over n minus 4. Okay? And that's as far as we're going to go on. Wait, number 11. An admission fee of $10 plus an additional $2 per game. If G is the number of games, be 10 plus 2 times G. Okay? Now, that covers some ideas on word problems. We're going to stop on the word problems there. I want you to go to the packet, page 1 in the packet, or if you look on course, it's listed as Module 4 packet. It's going to be in there, but it's got all of these pages, so just move down to this one. We're going to first talk about one-step equations in here. We're going to review things you did in 6th grade. Okay. Inverse operations. First off, to solve these, we're going to solve these. First, you locate the variable, determine the operation tied to the variable, use the inverse operation on both sides of the equal sign to solve. What are inverse operations? Well, if you're adding, the inverse is to subtract. If you're subtracting, the inverse is to add. If you're multiplying, the inverse is to divide. If you're dividing, the inverse is to multiply. Let's look at some examples here, okay? This is the first one on the page. X plus 7 equals negative 1, right? If I look at this, if I look at the equal sign on both sides, this is as simple as it gets, X and 7. I can't do anything with the X and the 7 because this is 1X and this is just numbers. I can't combine them. It's like apples and oranges. Okay, this is as simple as it gets. So I'm going to need to cross the equal sign. I need to get the variable, which is x, by itself. The 7 is added to it. So how about I add a negative 7? And what I do to one side of the equal sign, I must do to the other. Okay. Positive 7 plus negative 7 is 0. So I've just got x is equal to negative 1 plus negative 7. That's negative 8. There's my answer. Now, if I want to check myself, I plug this back in. X plus 7 equals negative 1. Does negative 8, see I've substituted negative 8 for my x. Does negative 8 plus 7 equal negative 1? Yes, it does. That means this is correct. The solution is x is negative 8. How about this? M minus 11 equals negative 9. I'm subtracting the 11. The inverse of subtracting is to add. I'm going to add 11 to both sides. Negative 11 plus positive 11 is 0. M is equal to negative 9 plus 11. Okay, and if you add negative 9 plus 11, you come away with 2. N is 2. How can I check myself? Here's how you check yourself. M minus 11 equals negative 9. Your M is 2. 2 minus 11 equals negative 9. When you subtract, it's the same thing as adding the opposite. That's 2 plus a negative 11. And that would be negative 9 equals negative 9. If they're equal, that means this is correct. Your solution is M is equal to 2. All right? 9 is equal to 14 plus H. I'm trying to solve for H. I would subtract 14 from both sides. H is equal to 9 minus 14, which would give me negative 5. How do I check that? 9 is equal to 14 plus H. 9 is equal to 14 plus negative 5. If I've got a 14 plus a negative 5, I've got 9. So this is correct. The solution is H is equal to negative 5. How about number 4 here? Okay, we're solving for the W. We need to get this negative 15 away from it. The opposite of subtracting a 15 or a negative 15 is a positive 15. In this case, W is equal to 29. How do we check ourselves? Okay, we plug it back in. Negative 15 plus 29 is equal to 14. And that is true. 14 is equal to 14. So it works. Your solution is 29. On this one, I have negative 21 equals k minus 8. I need to get the k by itself, isolate the k. So I do the opposite of negative 8, which is a positive 8, adding 8. All right. K then would be equal to negative, what would that be? I'm sorry, yeah, negative 13, correct? To check, let's see if this works. Is negative 21 equal to negative 13 minus 8? When you subtract a number, it's the same as adding an opposite. Negative 13 plus negative 8 would give you negative 21. These are equal, so it checks out. The solution is k is equal to negative 13. And then here on this one, let's solve for the variable b. Have a negative 4 here. The opposite of negative 4 is a positive 4. So we're adding a positive 4. Negative 1 plus 4 gives you 3 is equal to b. Now let's check ourselves. Is negative 1 equal to negative 4 plus 3? Negative 1 is equal to negative 1. So the solution to this equation is that b is equal to 3. Okay? So what if we are multiplying or dividing? Let's do some multiplication and division one step. This is 4 times a is equal to negative 24. So we need to figure out what's the value of 4. The opposite of multiplying 4 times a is to divide. A then is equal to negative 24 divided by 4, which is negative 6. How do we check ourselves? We plug this in, 4 times negative 6, and we see if that's negative 24. And yes, it is, because a negative times a positive would give you a negative. So the solution is negative 6. Now let's find the solution for P, the value for P in this situation. This is negative 7 times P. The opposite of multiplying is to divide. P is equal to, and that would be, I've got a negative divided by negative, which gives me a positive 8. 7 times 8 is 56, okay? Now to check our value, we plug it back in. Is negative 56 equal to negative 7 times 8? Negative 56 is equal to negative 56. So this is correct. 8 is indeed P. The value for P is indeed 8. How about this one? This is n divided by 5 is equal to 9. Okay, the opposite of dividing is to multiply. So I multiply both sides by 5. That's 5 over 1, so this cancels. I've got n is equal to 9 times 5 is 45. How do I check myself? I would say n divided by 5 equals 9. I would substitute 45 in for n. 45 divided by 5 is 9. 9 is 9. So this is true. N, the solution for n is 45. How about R2 is equal to R divided by negative 8? The opposite of dividing is to multiply. I'm going to multiply both sides by negative 8. These cancel. R is equal to negative 8 times 2, which is negative 16. Now let's check. 2 is equal to negative 16 divided by negative 8. Is 2 equal to 2? Yes, it is. So the solution for R is negative 16. Now let's look at this one. This one is probably going to be confusing for you. I just want to make sure you remember something, because there's nothing in front of the K but a negative symbol. When we have that, we realize that's 1K. So that's negative 1K is equal to 7. To solve for K, I divide both sides by negative 1, and K is equal to negative 7. Let's check this by plugging this in. I've got opposite of K equals 7. The opposite of negative 7, is that equal to 7? Well, if you've got the opposite of a negative number, that's a positive number. So yes, it is. So the solution for K is negative 7. I keep using the word solution because it's going to be important to you as we keep going here. This is x divided by negative 6 equals negative 12. The opposite of dividing by negative 6 is to multiply by a negative 6. What I do to one side, I do to the other. Your negative 6 cancels. X is equal to negative 12 times negative 6, which is positive 72. To check that, I would plug this in. I've got x divided by negative 6 equals negative 12. Let's substitute the 72 in place there. 72 divided by negative 6 equals negative 12. Negative 12 equals negative 12. This is indeed true. So the solution for x is 72. Now let's try a few of these down here. Okay. These are mixed practice. X minus 11 equals negative 3. If I'm subtracting 11 from both sides, the opposite of that is to add 11 to both sides. X then would be equal to 8, okay? Let's check that by plugging that in. X minus 11 equals negative 3. 8 minus 11 equals negative 3. Negative 3 equals negative 3, okay? If that's the case, then x is indeed equal to 8. Okay, the solution for x is 8. On this one, I've got negative 10 times d equals 40. The opposite of multiplying by negative 10 is to divide by negative 10. That would mean D is equal to 40 divided by negative 10, which is negative 4. Let's check. Is negative 10 times negative 4 equal to 40? A negative times a negative is a positive. That's 40 is equal to 40. That does work. The solution for D is indeed negative 4. How about here? A plus 15 is equal to 2. Adding 15, the opposite of adding 15 is to subtract 15 from both sides. So A is equal to negative 13. Let's check this. A plus 15 equals 2. Is negative 13 plus 15 equals to 2? Yes, it is. Okay, so that's checked. That means the solution for A is negative 13. Here I've got 24 is equal to negative 3 plus h. The opposite of a negative 3 is a positive 3. We're trying to get the h by itself, the variable by itself. Okay, that gives me h is equal to 24 plus 3, which is 27. Okay, now let's check ourselves. If 24 is equal to negative 3 plus h, and 24 is equal to negative 3 plus 27, then negative 3 plus 27 is 24. 24 is equal to 24. Okay, that means 27 is the solution. Okay, let's look at number 17. Negative 4 is equal to m divided by negative 3. The opposite of dividing by a negative 3 is to multiply by a negative 3. Okay, let's multiply both sides by negative 3. M would be equal to negative 3 times negative 4, which is a positive 12. Now let's check ourselves. Is negative 4 equal to m divided by negative 3? Well, let's put in our value. M is 12. Is negative 4 equal to negative 4? Yes, it is. So 12 is equal to m. 12 is the solution for m. Now, 9 is equal to negative y. We know if there's nothing in front of it, that means it's a negative 1y. The opposite of multiplying by negative 1 is to divide by negative 1. Y is equal to negative 9. Check to see if this works. 9 is equal to negative y. 9 is equal to the opposite of negative 9. The opposite of a negative is a positive, so it works. The solution is that y is equal to negative 9. Okay? Negative 47 plus w is equal to negative 10. I'm trying to get to the value of w, so I need to get all the numbers away from it. The opposite of a negative 47 is a positive 47. W is equal to 37. Let's check to see if that's correct. Is negative 47 equal to, or negative 47 plus 37 equal to negative 10? Yes, it is. Okay. So that means that W equals 37. The solution for W is equal to 37. P divided by 9 equals negative 9. The opposite of dividing by 9 is to multiply by 9. What I do to one side, I do to the other. That gives me P is equal to negative 81. To check myself, I would plug this in place of P. If I've got P divided by 9 is equal to negative 9, and in place of P, I put negative 81 divided by 9 equals negative 9. Negative 9 equals negative 9. That's true. The solution for P is negative 81. On number 21, negative 48 is equal to negative 16a. 16 times a, that means you're multiplying by 16. The opposite of multiplying is to divide, okay, by negative 16. You got a there, okay. If I divide by 16, that would be 3 times, right? Okay. Let's check ourselves. to check, you'd say negative 48 is equal to negative 16 times A. In this case, your A was what? 3. Negative 48 is equal to negative 48. That's true. So your solution is 3. Okay, minus 9 equals negative 38. The opposite of subtracting is to add. This gives me K is equal to negative 29. All right? Okay. Let's see, there's negative 29. Okay. All right, let's try this. Let's plug it in to check it. That would be negative 29 minus 9 equals negative 38. Negative 29 minus 9 is negative 29 plus negative 9, which would be negative 38. Okay? And these two are equal. Therefore, this is the solution. K is equal to negative 29 is the solution. Let's do the last two here. This is negative 20 is equal to V divided by negative 4. The opposite of dividing by negative 4 is to multiply by negative 4. V is equal to negative 4 times negative 20, which is a positive 80. Okay, to check that, you would plug it in. Is negative 20 equal to 80 divided by negative 4? Is negative 20 equal to negative 20? Yes, it is. Okay. And then this last one, 6 times n equals 0. So the opposite of multiplying is to divide. When I divide both sides by 6, I get n is equal to 0 divided by 6, which is 0. Okay, let's check that. If 6 times n equals 0, then that means 6 times 0 equals 0. And anything times 0 is 0, so that is indeed true. Okay? Now we've done some work on one-step linear equations, and we've done some work on word problems. All right? That's the end of Mod 4 Lesson 2.